Hello everyone. Today I will be showing you De Morgan's law. There was a mathematician, Augustus De Morgan, who was a logician and a mathematician. Now he gave two laws in the set theory. What are the two laws? If I say there exists A and B, which are sets. First law was A union B whole complement is equals to A complement intersection B complement. And the second law he told was A intersection B whole complement is equals to A complement union B complement. Okay, so there are like many ways to write a complement, or giving complement sign is also equals to x dash, or you can say it as x prime. Okay, now I will be showing you the proofs by both algebra and Venn diagrams. So before that, what is a Venn diagram? Basically, a Venn diagram is a diagram in which, so it's a diagram, or basically a diagram by which the relationship between some sets can be better understood by some pictorial representations. Okay, so this is basically a Venn diagram. Now let's move on to the proofs. So first, A union B whole complement is equals to A complement intersection B complement. Now suppose there exists X such that X belongs to A union B whole complement. Now by this statement we can say that X does not belongs to A union B. With this we can say X will neither belong to A nor to B, and so X does not belongs to B. Now what will be the connective between these two? It's the main idea of this proof. Okay, so the connective between them will be AND. Okay, so the next line will be, if it does not belongs to A, so it will belongs to the complement of that set. Now X belongs to A complement and X belongs to B complement, by which we can say X belongs to A complement intersection B complement. So therefore we have shown that A union B whole complement is equals to A complement intersection B complement. because if a element contains in this set, it also contains in this set, we have proved. So that means every element will belongs to this and this set, so therefore it's proved. Now let's move on to the Venn diagram proof. Now let's say there is a Venn diagram. So this is the pictorial representation. This is, suppose, A, this is B, and the whole box is known as the universal set. Okay, now look at the left hand side of the equation. So it says A union B whole complement. So that means it if this is A union B, so the outer region will be the A union B whole complement. So this is the A union B whole complement. So this is the LHS part, left hand side, and the RHS part will be, okay, so let's say this is A, this is B, and this is the intersection part, A, B. So A complement, what is the A complement? So we will break down this RHS into two parts. Okay, so A complement will be every region except A. So this is A. So if I draw with horizontal lines, this will be A, okay, and so what is, so this is A complement. Okay, now what will be the B complement? So the region except B, okay. Now it says A complement intersection B complement. So if you see at both the sides, A complement means except A everything is there. So okay, there's a mistake. So the intersected part will be there, because no, the intersected part will not be there, sorry, the intersection part will not be there because it contains in A. So if I say about the intersection of both these diagrams, it will be this diagram. Okay, this is A complement intersection B complement, because if you see that the common region is outside of A union B only. If you look at these two, the common region is basically this one. This one is the common region. Okay, so for the algebra proof, let's say there exists X such that X belongs to A union B whole complement. So by this statement we can say that X does not belongs to A union B. Okay, so if A doesn't belongs to A union B, it says that A does not belongs to A, X does not belongs to B, and what will be the connective? It will be the OR. Why? Because A union B are two sets having a common intersection, so it's a OR case, because X can either not belongs to A or not belongs to B. It can belongs to one of the set, but the other will not. Okay, now by this statement we can say that X will belongs to the complement of the sets. So by this we say that X belongs to A complement union B complement. Why? Because OR connective is there. So therefore A intersection B whole complement this will be intersection is equals to A complement union B complement. So the explanation that I have given right there in this statement was actually wrong at that case, because this signs I have put wrong. So if you look at the Venn diagrams, so this is A intersection B right there, and if you look at it, if X doesn't belongs to here, what it says, X can either belong to here or belongs to here. So if it belongs to here, it doesn't belongs to the other set right there. This is the correct explanation of this statement, how I've got from this to this. Okay, so I'm sorry for the previous explanation that I've given. So let's move on to the Venn diagram. So for the Venn diagram, we again will be taking LHS. So this will be A, this will be B. Now A intersection B is this part, so the complement of it will be this part. Right there. Now RHS. What about the RHS? Now we will again part wise understand what will be the RHS. So this will be A, this is B, and I forgot to give the universal sets. Okay, now look, A complement right there. So what will be the A complement except A, the shaded region that I am giving. Okay, now let's draw the B complement over there in order to understand it better. So if I say B complement, it would be like this. Okay, now if you see that these got some lines, this right there, and these set also got lines, but the common part is the outside one, right? Now see, they're giving that A complement union B complement. So the B complement set was right there. This is B, so B was like this. So A was only the A complement was only the outer shaded part of A. So if we take the union of it, we need to take whole. So the resultant Venn diagram will be like the LHS part. Why? Because union means what? We need to take OR case, because everything we can like the X can belongs to A or B, but not the intersected part, or it can belongs to the complements of A and B. Okay, so this completes our Venn diagram and the topic De Morgan's law.